Okay, good day everyone. So our topic today is congruent triangles. When we see congruent triangles, we mean everything about them is congruent. Their side and their angles. All three pairs of corresponding angles must be equal, and all three pairs of corresponding sides also are equal. For us to prove that two people are identical twins, we don't need to show that all 2000 body parts are equal. We can take a shortcut and show three or more things are equal, such as their face, age, and height. If these are the same, I think we can agree that they are twins. The same as true for triangles. We don't need to prove all six corresponding parts are congruent. We have five shortcuts or methods. So, let us determine these five. Number one, we have the SSS, or the side, side, side. The SAS, or the side angle side. The ASA, angle side angle. And the AAS, angle angle side. And the last one is for right triangles only, which is hypotenuse leg, or the HL. Now, let us define this or describe this one by one. First is we need this built-in information for triangles. This is just a recall. Number one, vertical angles. What is vertical angles? When we say vertical angles, those are opposite angles and they are congruents. Number two, take note the shared side. Shared side always is about the reflexive property. And the shared angle also is about reflexive property. Example, if we have side xy is congruent with side xy. So, two sides the same are congruent. XY is congruent to XY, or XY is congruent to YX. So the reason is they are shared side or reflexive property. Now, to recall what is congruent angles have the same measure. Example here, we have 160 degrees, the opposite is 160 degrees also. So, angle MRN and angle PRQ are congruent. So, this angle here, MRN and PRQ are congruent angles. And since they are congruent, they have the same measure. And we have angle MRP and angle NRQ or QRN. They are congruent because their measurement is 20 degrees. So, vertical angles are formed opposite each other when two lines intersect. Just like here in this example, we have line MRQ and line PRN. They are intersecting lines. That is why they form a pair of two pairs of vertical angles. So we have angle MRP and angle NRQ are vertical angles. And since they are vertical angles, so they are congruent. Angle MRN and angle PRQ also are vertical angles. Okay? So take note of this. If two lines intersect, opposite angles are congruent angles because they are vertical angles, and since vertical angles are congruent. Okay? Now, when two triangles touch, there may be additional congruent parts, like this for this example. Okay? There are two triangles formed here. One is this, and another one is this. Based on the mark, okay, part of the triangle, these angles are vertical. Okay? Vertical. This angle and this angle are vertical angles. So since they are vertical angles, then they are congruent. Now, how about this? What do you think are common in this, or equal or congruent in these two triangles here? One here and two here. Of course, they have reflexive side, or they shared the same side. What side is that? That side. Okay? If we are going to separate these two triangles, they have the same side. And the same side or sides are congruent. Okay? So now we are going to identify the built-in part of this given triangle. Number one here. What is the built-in part? Or when we say built-in, there is no other reason. There is no debate that they are equal. So this one, this side, the mark, this one, this side are built-in part because this is a common side or a shared side, and there is no debate that they are congruent. Okay? How about this secant triangle? The secant triangles, so we have the vertical angles. Because of these intersecting sides, then they are vertical. Okay? How about this? The same also. The built-in part here is the shared side. Okay, this part here. If we are going to separate the two triangles, they have common side here. Now, in this next triangle, we're going to determine what property or theorem we need in order for us to see that these triangles are congruent. Based on the given mark here, this side, okay, is congruent with this side. And this side, may duha ka line, this side also is congruent with this side. That is why, by SSS property, we can say that these two triangles are congruent because the shared common side. This one is the shared side. So if we are going to separate these two, we can say that they are congruent by side, side, side postulate. One side, a pair of next side, then the last side. So they have the same measurement in every side of this triangle. So by side, 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 or SSS postulate, we can say that they are congruent. Now, how about this? Okay, we have one side here, a pair of one side again, then one side, one side. So you have two sides congruent. So side, then the included angle at the center, side, angle, then side. The other triangle is side, angle, then side. So we can prove that two triangles here are congruent by SAS, or side, angle, side. Now, how about the third? The third one, if you are familiar with this symbol, the arrow, okay, and the line here with arrow, that means they are parallel. When we say parallel lines, the lines that do not intersect. If this line is extended, if these two lines will be extended, they will not intersect. Okay? So, if you can recall, if lines are parallel cut by a transversal, alternate interior angles are congruent. Alternate interior angles are congruent. So when we say alternate, example, this angle here is congruent with this angle. Okay? This angle here is congruent with this angle. Okay. That is alternate interior angles. We have AIA. Alternate interior angles. Now, we have one side congruent based on the mark here. One side congruent. Then we have an angle which are congruent. We need the last one, which is the common or the shared side. If we are going to separate the two triangles, we have side, angle, then side. So by SAS postulate, we can say that these two triangles are congruent. Okay. Because of that common side. So here are some reasons for indirect information. Number one, definition of midpoint. When we say definition of midpoint, example if we have side, if this is the line, okay, if this is the line and the midpoint is here, then the midpoint divides the line into two segments. Okay? The midpoint divides this line, the line, into two equal segments. When we see midpoint, so ara agad siya sa center. So, therefore, by definition of midpoint, you can say that this segment here is congruent with this segment. That is the use of definition of midpoint. Now, definition of a bisector. When we see bisector, from the word itself, bisect, it divides the part into two equal measurement. Example, if I say definition of angle bisector, so the angle is divided into two equal angles. Example, if ang line bisector divides the 90 degrees angle, so that bisector divides the 90 degrees into 45 and 45 degree angles. Okay? Next, vertical angles are congruent, as what we have learned earlier. Vertical angles are always congruent. Next, definition of perpendicular bisector. When we say perpendicular bisector, if this line here, then one perpendicular, if this one is the perpendicular bisector, then this line here is perpendicular to this line and it form a 90 degrees angle. So this bisector form a 90 degrees angle or a right angles. So that is definition of perpendicular bisector. Next, we have reflexive property. An example of those is the shared side, reflexive, the same. XY is congruent with XY. Angle A is congruent with angle A. Angle B is congruent with angle B. That is reflexive. Parallel lines. So, in parallel lines, take note, alternate interior angles are congruent. Again, in parallel lines, alternate interior angles are congruent. When parallel lines cut by a transversal, alternate interior angles are congruent. Next, property of perpendicular lines. When we say perpendicular, there is no reason that it forms a 90 degrees angle. So if you can see that one angle of the triangle is 90 degrees, maybe you can use this one of the reasons, property of perpendicular lines. This is called a common side, the center here. This one is the common side. It is a side for both triangles. We will use the reflexive property when we give reason. Example, if this side here, if this side A, B. So you can say that side AB is congruent with side AB. The reason is reflexive property. That means they are common side. Now, hypotenuse leg. Hypotenuse leg is used only with right triangles. But you know what? Not all right triangles. Now, in hypotenuse leg theorem, when one or a pair of hypotenuse are congruent and one side are congruent, then by that postulate we can prove or we can say that the two triangles are congruent. Example here, if this side, which is the hypotenuse, is equivalent with this side, which is a hypotenuse of the next triangle, and they have a common side or the shared side by reflexive property, then we can say that this triangle is congruent or equal with this triangle. I hope that is clear to everybody. Now we are going to name that postulate. Name whenever it is possible. Now, on the first pair of triangle here, we have side, we have angle, and we have shared side. Again, we have side, which is equivalent to this side. We have angle, which is equivalent to this angle. And we have common side. Therefore, we can prove that these two triangles are congruent by reflexive property, and that is SAS postulate, side angle side postulate. How about this? Okay, the next triangle, we can see a vertical angles. Okay, so since vertical angles are congruent, so we can say that this angle is congruent with this angle. Now, based on the marked part of the triangles, this side here is congruent with this side. So by vertical angles, this angle here are congruent with this angle, and this side here is congruent with this side. Therefore, by side angle side postulate, we can prove that the two triangles are congruent, side angle side. Next, here, the vertical angles, right? We can see a vertical angles here. This angle here and this angle here are vertical angles. Now, take note, we have side, angle, and side. So by SAS postulate, we have proven that these triangles are congruent. Now, the next triangle, here, we have a marked side, 1, pair with this, equal, and angle with this angle. Now, what do you think? Are these two triangles equal? Since they have common side, right? Common side, so side, then side, common side, then side, then angle. Do we have SSA property? Okay, by reflexive SSA, we don't have SSA. We have SAS, we have ASA, but no SSA. So we cannot prove that they are equal or congruent. Now let's practice. Indicate the additional information needed to enable us to apply the specified congruence postulate. So here, for ASA or angle side angle, we have angle side. So we need at least angle B is congruent with angle D. Okay, angle side. So we need to prove if this will be marked as equal, then we can prove by ASA. So we need this specified part of the triangle. How about if we're going to solve for SAS? Again, is AS. So we have S, we have A. We need one side. So what side is that? Is it AB and FD or AC and FE? The right is we have side AC. It must be side AC congruent with side FE in order for us to prove that these two triangles by SES. Again, S, side, angle, it must be this side. Okay? Side, angle, it must be this side. How about if angle, angle, side? Or angle, angle, side? Maski wala na si side, at least two angles, okay na siya. Angle, angle, side, we have the angle, okay, angle A must be congruent with angle F in order for us to prove that they are congruent by angle, then angle, side. Angle, angle, side. Okay. Now, determine if whether its pair of triangles is congruent by SSS, SAS, ESA, or AAS. If it is not possible to prove that they are congruent, write not possible. We have examples here. Example number 4. We have a marked part which is GH is congruent with key J. Basta may mga mark, isa lang gani against isa. So, buting ganon, they are congruent. Okay? So, we have side GH and side KG are congruent. What else you can see congruent? So, we have angle G and angle J. So, we have angle, side, and angle and side. But what's the most, should I say, closer reason or part in which we can say that they are congruent? Based on what we have learned earlier, we have this one. This angle. Okay? This angle here. Angle GIH and angle KIJ or JIK. What is the reason? They are vertical angles. So we can prove that the two triangles, triangle GHI and triangle KIJ, are congruent by AAS postulate. Next example, we have angle, then side, then angle. Angle, then side, angle. So everything is complete. So we can say that they are congruent by ASA. They are congruent by ASA. Next, they are congruent by, so we have side, side, and vertical angles. Okay, vertical angles and this side. So side, angle, side. Side, angle, side. So kung ibutang na to na sa reason, side EC is congruent with side AC. Given ang reason. Side BC is congruent with side CD. Ang reason is given. Angle ACB and angle ECD, they are congruent. Ang reason is vertical angles. So by SAS postulate, we can say the triangle ACB is congruent with triangle ECD by SAS postulate. Okay? Example number 7. We have side JM and side KL are congruent. Next, we have JK and ML, they are congruent. Now, oh no, not they are congruent, they are parallel. So JM and KL are congruent given. Then angle, right? Since they are parallel, this angle must be congruent with this angle. Or this angle is congruent with this angle. So we have side, angle. Then we have common side here. So that is why triangle JMK is congruent with triangle LKM by SES or ASA. Okay, A angle, side, angle. Pwede na siya. Angle, side, angle. Or side, angle, side. Okay, naunhan ko na. Determine whether if it's paired. So, look at the two triangles. JK is congruent with TU. KL is congruent with UV. But here, we have side, side, angle. Angle L is congruent with angle V. But again, there is no S as a postulate. So we cannot say that they are congruent. So this is not possible. So I hope you learned something of the reasons and the principles based on the postulate we have learned today. So thank you for watching and God bless.